definitions. We're laying out the different parts of linear functions. Okay, we've already covered domain and range. We've not covered increasing and decreasing intervals or positive, negative, but we're going to cover that. So let's look at this. We've got the slope of a function, the set of all x values for a what's that? The set of all x values for a function. The set of all x values. The set of all x values is your domain. Isn't that what we've already practiced? So domain's already covered. The interval where the graph rises and the y value increases. The point where a graph crosses the y-axis. The behavior of the graph as x approaches positive infinity or negative infinity. The set of all y values for a function. What's that? Range. Range is A. The points where a graph crosses the x-axis. What? X-intercept. Makes sense, right? It's intercepting the x-axis. B. So then what is the point? I'm going to back up. What's the point where the graph crosses the y-axis? Y-intercept, right? Where it's intercepting the y value, the y-axis. So that would be E. Now what's left is part of stuff that we're going to learn, stuff you've talked about before in the past, that's it. So the slope of a function. Do you remember slope from middle school? Do you remember a phrase to represent slope? Yes, nice. Rate of change is a fancy way to represent slope. You may even want to write it next to it so that you can go ahead and tie that phrase together. If I say the rate of change, I'm definitely just talking about the slope. I'm asking what's happening to the y's as what's happening to the x's. Now, looking at what's left, we got in behavior, increasing interval or decreasing interval. Let's look at our definitions. The interval, blah, 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 blah. The behavior, blah, 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 blah. The interval, blah, blah, blah. Which one can I deduce based on the definitions? In behavior must go with the definition that discusses behavior. So now let's read it. In behavior is the behavior of the graph as x approaches to the right or up, and then as y approaches to the left or down. That leaves us with increasing interval and decreasing interval. The interval where the graph rises as the y value increases. Would make sense to make that the increasing interval, right? Then look at the one left. The interval where the graph falls and the y values decrease. So increasing is 3, decreasing is h. Now, looking down here, we got linear parent functions. We're going to graph this, and then we're going to talk about the different parts. So here's our function. We have f of x. Remember, that's how you read this. This is f of x. That's how you say it. It means it's function f, where x is your input. Then you'll notice that this part over here, this is the actual equation, or you can say formula. The formula is when you get x, you're going to plug it into the formula x. Does that mean, what do we do with it then? If the formula is just x. Like if the formula were 2x, that would mean you do what with it when you plug x in? You'd multiply by 2. The formula is just x, so you just leave it alone. 940. 940.
Why are you so excited to leave?
So we're just going to plug it in. Here's our input. Let's write the output. If I plug -2 into that function, what would I get? -2. We just talked about how it doesn't change anything because it's just x. So I would get -2. If I plug -1 in, I would get -1.
So would it be like a straight line?
What?
So would it be like a vertical straight line to the graph?
It's not vertical.
So it's horizontal.
It's not strictly horizontal either. It's definitely changing, as it's going up and down. If I plug 0 in, what do I get? 0. Cooper, if I plug 1 in, what do I get? Nice. Brandon, if I plug 2 in, what do I get?
2.
Thank you. Now we're going to plot this and we're going to assume the rest of the line would continue in this pattern. We can't possibly list all the points on this graph because this is an actual function. This is linear, which is what we're getting into. So let's plot these to see where it is, and we're going to draw our continuous graph through it. -2, -2 would be left 2, down 2. -1, -1, left 1, down 1. 0, 0. Right 1, up 1. Right 2, up 2. Now you can see where the line is. Now what we're going to do is draw a continuous line through that. I'm going to cheat because I have the program, the software to do it. So here we go. We're going to draw a line. Now this line does continue going. So what should I put on the end of it? In arrows, right? You want to put arrows because this is going to keep going. So your graph should match mine. All right. You should already be able to answer domain and range. Domain is what would be covered by the x-axis. If I was to go and highlight like up and down, think of those bars. Then range is what would be covered by the y-axis if I turn my head sideways and if I highlight left and right. So take a second, look at it, and think of what the domain and range would be. What did you notice is going to get covered? Like domain and range, what's going to get covered? What? Say it louder. You're right. Everything. The entire x-axis is going to be covered. So how do I represent that without saying the whole x-axis? What do I write? Negative infinity to positive infinity. Very good. So this whole, and it's because as the arrows are going down, they're also going left. As this arrow is going up, it's also going right. So if I sat here and said, what all is getting covered, it's going to be the entire x-axis. Now turn your head sideways. What all is getting covered on the range? Everything, because it's going down and it's also going up. So again, the range would be negative infinity to positive infinity. Now, the next part, what's the x-intercept? This is where it's crossing the x-axis. It's crossing at 0, 0. That's one way to write it. You could also say x is 0 when y is 0. That's another way to write it. What is the y-intercept? Turn your head sideways, look at the y-axis.
0.
No, this is, okay, so that's a great question. When you're writing the coordinate point, it looks like interval notation, but it's not. It's definitely just a point. And because it reads what's the x-intercept, it's assumed that you know we're not talking intervals, we're talking coordinate point. What's the x-axis or x value, what's the y value? What's the y-intercept?
0, 0.
Yeah, in this particular case, your x-intercept doubles as your y-intercept. That is possible. Now, the next part says, what is the interval of increasing and what is the interval of decreasing? Then it says, what's your left-end behavior, what's your right-end behavior. So here's where it starts to get challenging because the state could go like 3 different ways to write this. And so I've been looking into like how is the state writing it because that's how I want you to write it. So we're going to just kind of cover all of our bases and then stick with the one that the state covers the most. With our intervals of increasing, this means you're reading it from left to right. Not a lot of places right here to write a note, but I want you to imagine scanning it from left to right. What's the graph doing?
Increasing.
The whole time. What's it doing? It's increasing. Okay? Can you describe, just like you did domain, what's the interval it's increasing? Imagine highlighting again. What's the interval it's increasing?
To the right.
Do you notice that it's increasing the entire time?
Yes.
So, just like the highlighted thing with domain, you're saying it's increasing all the way from negative infinity to positive infinity. Now, if you don't understand that, that's okay. As we practice this more, you're going to start to understand it. Is there anywhere on the graph, as I scan my eyes from left to right, where the graph starts going down?
No.
Does everyone see that the answer is no here? I'm scanning my graph from left to right. With my shadow, my pointer, you really can tell, but if you were watching the video, you can't tell. But basically, here we go. I can do it. We drop a pointer. There you go. So as I'm scanning this graph from left to right, notice that it is ascending. At no point did the graph start going down, which means, is there anywhere on the, think of a roller coaster, is there anywhere on here that was like a roller coaster going down? So there is no interval of decreasing. Now the next part, what's the left end behavior and the right end behavior? This part looks really fancy, but it's as simple as what's happening to the left of the graph, what's happening to the right of the graph. It's saying, as you, let me show you how to read this. As you scan the x-axis and go left, look how to read this. As you scan the x-axis and go left, meaning as you look to the left of the graph, what's the graph doing? It's going down. So what is that when you go down? Negative infinity. So you're saying that the y's are going to negative infinity because the graph is going down. This is really complicated and we will practice it a lot. Now we're going to look at the right end behavior. This means, look how to read it. As you scan across the x-axis to the right, what is the graph doing? Meaning, what are the y values doing? As I go to the right, the y values are going up to positive infinity. All right, and then the last one, and then I'll let you pack up. It says average rate of change from x equals 0 to x equals 2. If you recall, here is the formula for slope. Remember this? Phi2 minus y1 equals x2 minus x1. What is the y value when x is 0? When x is 0, y is 0. What's the y value when x is 2? Here's 2. What's the y value? 2. So let's plug it in. You remember how to do this? You're going to plug it in. You're subtracting your y's over subtracting your x's in the same order. So if I do 2 minus 0 on the top, I got to do 2 minus 0 on the bottom. I get 2 over 2, which is what? 1. So the average rate of change is 1. Your homework is to, you can leave the guided practice for me since it is a word problem, but you have 3 practice problems on the back, okay? 3.